Hello. This video belongs to the AutoSTEM project. And in this video I will show you how you can teach mathematics and science for preschool children and even secondary school children just by using a simple mechanical toy, a catapult, that the children easily can make by themselves. We start with a simple game. I have a bunch of counting bears and they want to participate in a flying competition. Who will fly the furthest? Before we actually launch the bears, we ask the children and they can guess. So what do you think? Before we guess, we should collect some more information about the bears. Bears of equal size have the same mass. The medium bear weighs twice as much as a little bear. The largest bear weighs 3 times as much as a little bear. Young children can use a balance to compare the weight. Older children may want to use digital scales. The little bear has 4 grams, the medium bear 8 grams, and the large bear 12 grams. Have you made your guess? Then we can start.
Fa la 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 la. Launch! Fa la 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 la. Launch! Fa la 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 la. Launch! Fa la 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 la. Launch! Fa la 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 la. Launch! Fa la 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 la. Launch!
Now we can look at the result. The children can compare directly because it is very clear which bear travels the longest distance. We can measure as well, and the children can use the planks as units. The first bear traveled 13 planks. We can use a measuring tape to find out how much this is in centimeter. The second bear traveled only 9 planks, or 110 centimeter. The third one 10 planks, the fourth one 17, the fifth 10 planks as well, and the sixth, the last one, only 5 planks. There seems to be no correlation between the size of the bears and the distance they traveled. Perhaps some children will notice that we made a mistake. The question was not which bear travels the longest distance. The question was which bear flies the furthest. We have to look at the points where the bears landed, not where they stopped at the end. The landing spot is difficult to observe, but technology can help us. We can watch the video in slow motion and stop it when the bear reaches the ground. We can do the same with all 6 bears. Now we see a pattern emerge. The smaller the bear, the longer is the flying distance. Is this what you expected? How can we understand this? We can look at the energy. When I press down the catapult arm, I apply a force over a distance. That is what we call work in physics. Work is energy. This energy is converted into elastic potential energy within the catapult. When I release the catapult and fire the bear, the total potential energy is converted into kinetic energy. We can assume that every bear gets the same amount of energy. The kinetic energy of an object depends only on the object's mass and its velocity. If two objects have the same kinetic energy, the lighter object must have a higher speed. That means the lighter the bear, the higher its velocity. The higher its velocity, the further it flies. In secondary school, we can use the same simple experiment to analyze the ballistic trajectory. The students can use, for example, GeoGebra to find the equation of the parabola. When they compare the modeled parabola with the theoretical equation, they can calculate the launch angle and the initial velocity, as well as the maximum height and the horizontal range. We can use the initial velocity to calculate the kinetic energy. It is 0.04 joule. We can do the same exercise with a heavier bear. The trajectory is a parabola as well, and by comparing the empirical found data with a theoretical equation, we can calculate the launch angle, the initial velocity, the height, and the range. The velocity we can use to calculate the energy. And now we can compare the energy of the fifth bear with the energy of the first bear. We do not get exactly the same amount. And an explanation for this is the air resistance. The air resistance is proportional to the square of the velocity. That means that the faster bear meets a higher resistance and it loses energy to the air. Therefore, his initial energy seems to be lesser. Such a little toy and so many possibilities. Even more than I can cover in this video. For more information, please visit our website and watch the videos on YouTube.